At the first glance, these mathematical equations do not seem quite interesting and maybe not much useful, but if we change those conventional xy variables with actual measurable quantities, then we can see the usefulness of these equations quite clearly. Like here, those equations tell us about the on-off timing of the blink circuit that is built around 555 timer IC, and those XY variables are now representing the frequency, resistance, and capacitance. Now, controlling the blink rate of an LED using mathematics seems a lot of fun, and in this video we will do exactly this, so let's jump into it. First, we'll build the circuit and then we will go for controlling it. To build the circuit, we need a breadboard, a 555 timer IC, an LED of any color, 47 microfarad capacitor, a 220 ohm resistor, a 0.01 microfarad capacitor, two 20 kilo ohm potentiometers, some connecting wires, a power supply, and one digital multimeter. After setting up the breadboard, the timer IC goes to the middle of the breadboard. Connect pin 1 to ground, pin 2 to pin 6. The positive end of 47 microfarad capacitor goes to pin 2 and the ground end goes to ground. Pin 3 to the separate rail. Connect the positive end of the LED to that rail. Connect one end of 220 ohm resistor to the negative leg of LED and the other end of resistor goes to ground. Pin 4 to pin 8. Connect one leg of 0.01 microfarad capacitor to pin 5 and the other leg goes to ground. Connect two potentiometers on the breadboard like this. Connect the extreme left pin of one pot to pin 6 and the middle pin to pin 7. This is gonna be R2 mentioned in the formula. Extreme right pin of the second pot goes to pin 7 and the middle pin goes to pin 8. This is R1. Now connect pin 8 to positive rail. Now it's time to control it. We have built the circuit and it is working properly. Let's go through the formulas. F is the frequency or blink rate of LED. T is the time period for which the LED stays on, plus the time period for which it stays off. TH represents on or high time only, and TL represents the low or off time only. Now, first I put the existing resistances and check how much frequency I get. My guess is about 3 blinks per second. The resistance 1 I get is about 1.66 kiloohms and the resistance 2 is 4.12 kiloohms. The capacitance has fixed value which is 47 microfarad. We put all the ingredients into the formula and we get the frequency of 3 Hz. The time period we get from the formula is about 0.333 seconds, and the high time, or the time for which the LED remains high or on, is about 0.187 seconds, and the low time for which the LED remains low is 0.134 seconds. Now the actual usefulness of this process comes when we give a known frequency to the formula. This means that we can get any blink rate by changing the resistance, or by getting the values for the resistance from the formula, set that resistance on the pot and simply get the blink rate. Say for example, I want the frequency of 5 Hz. Now I know the frequency. Now I set R1 equal to R2 for simplicity and get a relation in which R is unknown. In my case, as I set the frequency of 5 Hz, I get R equals 2042 ohms. Now I set both the resistances to 2042 ohms. You can see the frequency is now 5 blinks per second. In this video, we saw a connection between mathematical formulas and physical world. That is the usefulness of mathematics. We can predict, we can solve, and we can explore more about the physical world. See you next time.